Hello, Algebra students. I hope you are doing well. We are in section 8-4, and we're talking about squaring binomials, special cases. So what I'd like for you to be able to do by the end of this lesson is to square binomials and square differences of squares. You are going to notice that this is very similar to what we've already done. It's just written a little bit different because these are special cases. So sometimes when we are multiplying two binomials together, it is written a little bit differently. So what that means is if you have an exponent of 2, we're still multiplying a binomial with a binomial. So recall what an exponent of 2 means. So for example, if I had x squared, that's equal to x times x. Or what if I had 8 squared? If I had 8 squared, that would equal 8 times 8. So that's going to be the same thing with these examples. So it says write each expression in expanded form. I cannot say x squared plus 3 squared. No, it's the whole thing that's getting squared. So it's going to be x plus 3 times x plus 3. I'm expanding it out, and now it's just written as two binomials side by side. For the next one, if I'm expanding this out, it's 2x minus 7 times 2x minus 7. For my last expression, I'm just expanding this out. It's getting squared, so that means it's 3x plus 5 times 3x plus 5. And we're done with that first part. Now, when you see a binomial is squared, you should rewrite it and then multiply the binomials together. Do not try to do it in your head because it's very easy to accidentally miss a step. So we're going to be foiling in these examples again. So first, I'm going to rewrite this expression as two terms. X plus 8 times x plus 8. And then I'm going to use the FOIL strategy that we talked about in a previous lesson. So FOIL is going to stand for first, outer, inner, and last. So let's take our first terms of each set of parentheses and multiply them together. X times x, that's going to get us x squared. Now take your outer terms, x times 8. Multiply those together to get us 8x. Multiply your inner terms, 8 times x is also plus 8x, and 8 times 8 is going to get us 64. I can combine these like terms, so I have x squared plus 16x plus 64 for my final answer there. All right. Next, I want to square 2x minus 5. Remember to rewrite it so you don't accidentally miss a step of your foiling process. So, I'm going to rewrite this first as 2x minus 5 times 2x minus 5. Now I'm going to take the first term times the first term and multiply those together, getting me 4x squared. 2 times 2 is 4. X times x is x squared. Then I'm going to take 2x times negative 5, which is going to be minus 10x. After that, I'm doing my inner terms, negative 5 times 2x, which is once again minus 10x. And then I have negative 5 times negative 5. Well, a negative times a negative is a positive, so I have plus 25. I have like terms in the middle, so negative 10x minus 10x is negative 20x. They're not going to cancel because they are not opposites. Remember, for two things to add to 0, you're going to need a positive and a negative. So we have 4x squared minus 20x plus 25. And there's our solution for that one. Continuing on for example C, and I accidentally wrote C twice, so this one's actually D. There. For C, I have 3x plus 4 squared. Remember, when we square something, that means multiply it by itself. So I have 3x plus 4 times 3x plus 4. And now I'm going to do FOIL. So first term times first term is 9x squared. Outer terms, 3x times 4 is 12x. Inner terms is 4 times 3x, which is 12x. And then my last terms of the parentheses is 4 and 4, so that's going to be 4 times 4, or 16. Now, in the middle, I have like terms. 12 plus 12 is 24, so I'm going to have 9x squared plus 24x plus 16, and there is my solution. I have one more example doing it like this, where we have x minus 9 squared. Rewrite your expression as x minus 9 times x minus 9. And then we'll do FOIL. So first term times first term, x times x. X times x is not x, it's x squared. Because remember, when I multiply something by itself, it is going to have that square value onto it, or that square exponent. And then I have x times negative 9, which is going to be negative 9x. I know that it's negative because of the minus sign right here. Then I have negative 9 times x again, which is negative 9x. And finally, I have the last terms being multiplied together. Negative 9 times negative 9 is positive 81. I'm getting positive because a negative times a negative is a positive. Finally, we need to combine our like terms, so that's going to be x squared minus 18x plus 81. And then I'm done with that one. So this is very similar to what we've already done with the FOIL method. The only extra step is that we have to expand it out so we can see our two binomials getting multiplied together. Now there is one other type of special case we're going to talk about, and this other special case is something called a difference of squares. A difference of squares is when you have a positive and a negative constant in each binomial. So the parentheses are going to look just about the same, except one is going to have a plus sign and one is going to have a negative sign. And what's going to happen with this is when you have a plus and a negative, the center terms will cancel out. So that's why these are special. We're still going to follow the same strategy as before. So we're still foiling, but something unique is going to happen with these. So let's multiply x plus 8 times x minus 8. Notice how these parentheses look really similar, but one has a plus and one has a minus. That's what makes these different. So I'm going to do first outer, inner, last again. So I'll write FOIL up here again. And we've got first, outer, inner, last. Okay, and so first meaning the first term in each set of parentheses, outer meaning the outside parts, inner meaning the inside most terms, and last meaning the last part of each set of parentheses. Okay, so I'm going to have x times x, which is x squared, and then x times negative 8, which is minus 8x. Then I have positive 8 times x, so that's going to get me plus 8x. And then positive 8 times negative 8 is going to be negative 64. It's negative because a positive times a negative is a negative. Now, when we combine like terms, notice what happens here. Negative 8x and positive 8x are opposites of each other, so they add to 0. You don't need to put plus 0 in the middle, so all we have to do is say x squared minus 64, and we're done. All right, let's do that again. I have 2x plus 9 times 2x minus 9. The plus in one and the minus in the other is what's going to cause there to be something canceling out. So let's do FOIL. First term times first term. 2x times 2x is 4x squared. 2 times 2 gets me the 4. X times x gets me x squared. Okay, now I'm taking 2x times negative 9. Well, that's going to be negative 18x. Now I'm taking positive 9 times positive 2x, which will be positive 18x. And then I have positive 9 times negative 9, which will get me negative 81. Okay, now that I have all of my terms multiplied out, I want to combine like terms, but as you can see, these guys are opposites of each other. So they are going to cancel each other out, and all I'm left with is 4x squared minus 81. We just have 2 more examples, and then we'll be done. So in example C, I have 3x plus 1 times 3x minus 1. I'll go ahead and show this example with distributive property just so you can see it like that one more time. With the distributive property, I need to take this 3x, multiply it by both things. So that's going to be 3x times 3x minus 1. And then I'm going to take this plus 1, and it also has to get multiplied across the parentheses. So it's going to be plus 1 times 3x minus 1. Now I want to distribute across both of those sets of parentheses. And that is going to get me 9x squared minus 3x. So 3x times 3x is 9x squared. 3x times negative 1 is minus 3x. Then I have this 1 that I'm distributing, so 1 times 3x is plus 3x. 1 times negative 1, this is times, so they're not going to cancel. 1 times negative 1 is negative 1. All right, in the middle, my negative 3x and my positive 3x cancel each other out. So all I'm left with is 9x squared minus 1. We have one more example. We have x plus 6 and x minus 6. So if we follow FOIL again, then we're going to have the first term times the first term, which is going to be x times x. X times x is x squared. After that, I'm doing outer terms. X times negative 6. I'm getting the negative because of the minus sign right here. So that's going to be minus 6x. Now I'm doing inner terms. The insidemost terms are 6 and x. So 6 times x is going to get me positive 6x. And finally, I have positive 6 times negative 6. When I multiply those two things together, I get negative 36. All right, my middle terms cancel once again. So I'm getting x squared minus 36. Now, we do have to have that plus and minus sign in each of our parentheses for these difference of squares, but you also have to have the same constants and variables. So notice how the x is the same and the 6 is the same. It's just the signs that are different. So I don't want you to think that just any pair of binomials with a positive and a negative will cancel out like this. It does have to look quite specific for it to be a difference of squares. But we'll be practicing with this more in class in the future. So make sure that you bring questions to me if you have any, and have a good night.